Hi everyone, welcome to part 3 of our helpers refactor, text mode refactor I guess, text model refactor I should say. Right, so we are a little bit lost at the moment, so let's try to understand where we were, because we had a bit of a break and it's always difficult to load up state. So we're halfway through our sprint, a bit more than halfway. The big objective of this sprint is, well, the first objective was done. We're in our second objective now, the big merger of the text models. And what we have done so far was to create a common interface for the helpers, I believe. And then, yeah, in fact, that's what was the problem, I think. Once we finally created a common interface, we then realized there's a whole lot of problems, because one of the methods that we have in the assistant, if I remember rightly, was pulling in a lot of functionality. So let's just look at the helper base class, I guess. This is the difficulty of this kind of work. You have to keep a lot of state in your head. Of course, if you do this infrequently enough, it's difficult to remember where we left off. So yeah, so the problem was this chap, I think, is streaming enabled. In order to do streaming enabled, we needed to know of the streaming properties, and the streaming properties were in the context. And we had made some kind of executive decision as to the level of hackery we were willing to tolerate here. See if we left some notes. Not huge amounts. In fact, it's not this task that we're in. But this one. Right, we'll have to stick to about an hour for this session. Right, so we didn't leave any particular notes here, annoyingly. But the gist of this is that in order to determine whether streaming is enabled, we need to know of the streaming properties. In fact, it's not even streaming is enabled. I think that's alright actually. I think we've already done streaming is enabled. What we did not do is streaming for type, I think. And that is the thing that requires access to the streaming properties. So let's have a quick look, see if we started implementing this method. Yeah, as you can see here, this is where it all kind of comes to grinds to a halt. Let's see if we've got the template where this was happening. Perhaps streaming for type. I would guess probably an IO, right? So let's just see if we take something like inserter implementation helper, which is not even really a helper. Let's just have a quick look at what's causing this problem. I wonder if sometimes we've done something a long time ago and may not make a lot of sense. Did we not copy it? Okay, not sure what's going on there, but here we are. So this is a classic use of streaming for type. So we're going to have some properties that are supplied for this particular type, and these properties, so there is the whole refactoring around streaming that we have not done yet. It would be valuable at this precise point in time, because if the streaming property was together, as it should be really, if the streaming property was together with the attribute, so presumably we must be going around. Let's just have a quick look at how this streaming per type is implemented actually. I mean, we obviously did not want to spend too much time in all this stuff. We're supposed to be doing something quick here, but clearly it's not quite how it's panning out. So the streaming properties are here. We look for a streaming property, and then with the streaming property we have a whole lot of things that we need to determine, and then a whole lot of hacks going on here. And right, so this is the way you're gonna. This is kind of a nest of wasps, so we don't want to be touching any of this stuff right now, because clearly this is going to be very painful. So instead, we just need to figure out how one would be able to call streaming for type here. We could change. Yes, okay, right. Then this is probably what we decided now. What we've probably done is we decided to change the helper interface. In fact, we had it just in front of us. So I bet you we changed the helper interface such that apply. We hadn't. Oh yeah, here we go. So apply now has a logical model. Okay, so that sounds sensible, right? So apply now has a logical model. Logical model has streaming properties. Okay, that's fine. Of course, the logical model will only work for now, of course, because we have context as the logical physical space. So that's fine. In the future this will be a problem, but let's just confuse one issue at a time. So we take this change then, and then what we're going to do is we're going to basically say streaming for type requires I mean, I'm just going to be lazy and ask for the entire model here. Clearly we don't have to, but and then if we ask for the entire model, we could just say something like model.streaming properties. And now the second problem is we need to have an ID of some kind. Not clear what n would have been, so let's just have a look at what the assistant would say. CPP assistant. So if I look for streaming for type, there's the guy, and streaming for type, streaming properties. We probably are in C# perhaps. No, C++. So, oh, there's two of these guys. Okay, fine. Right, we just have to be careful that we implemented all these permutations. Which I don't think we have, but let's look at the right permutation, which is this guy here. So, this guy is asking for seems to me that we've confused these two methods actually. So let's just look at what we got here. So streaming for type. One requires a string, another requires a logical name. Seems to me that we have borked all of this. Right, there we are. So these are the public interfaces. And as you can see here, we are changing quite significantly the existing interface. Not ideal. So streaming for type. helper descriptor. I think we were trying to be clever here, and that didn't really pay it out, I think. Let's just try to put this the way it was. Right, so this guy requires a logical name. Well, in addition to a logical name, we're definitely going to require a model and then a string. This guy has a helper descriptor. In fact, I'm just going to change the signature slightly. So first thing we supply is the model. And sadly, I think this is going to be... Well, actually, it may not be in all cases, so we just have to look very carefully how this is implemented. So, in this particular case, we're calling streaming for type, and clearly we're not going to need to look up the model because we already have the helper descriptor, so that's not an issue. So I don't think we need a model for this case. Just needs the helper descriptor and a string. In this case, we need a model. We have a name. We have to do lookup, and away we go. And that is the implementation method, so that's fine. We should leave it on that. Now then, let's look at how this is implemented. So, first case. First case, actually, we're going to copy and paste this guy here. So, nothing particularly special. Second case, we take a model. We shouldn't really need the helper descriptor given that we have a model, so that signature must be wrong. It must be that we needed a logical name and we need a string. Now that seems a bit more sensible. So we take the model and we search, and the name is the thing we're searching for, and away you go. So now this is actually making some sense. And finally we have the implementation method, which for all intents and purposes could be private, because we don't expect anybody to need it, since we are the only ones accessing. Right, there we are. So now that's making a bit more sense. We have two public, well, I would say protected really, because only our descendants are going to use these methods. They require the model, well, at least one of them does. I think we should respect the order of implementation. So it requires a model, and it will be implemented as follows, okay? So hopefully this now resolves the problem here. Now, of course, every single helper is now implementing this interface. We have now said that we need a model, so we've broken all of the generated code. So let's just create, I think we don't have an RG area. Let's go for 9 perhaps. Probably don't need that. So let's create an RG here. And what we really want is to locate anyone that's implementing an helper transform. I'm just going to be quite broad in this first search. Right, so there's a lot of stuff coming through that's not really what we're looking for. So what we want is perhaps some kind of implementation. Here we go. So public helper transform, that perhaps would help things out. So most interesting. Not many are inheriting from the helper transform. is very puzzling. Let's just switch from RG to grep, I think, because RG does a lot of clever things. Sometimes you want something a bit less clever. But no, it does confirm our theory that we must have started this exercise but not gone very far. So that being the case, what we'll need to do then is let's just of course the problem we now have is that we're going to have a lot of helpers around here. Ah, okay, that would explain it. So the reason why we don't see it is because it's fully qualified. Okay, no problems. So let's just try that yet again. Okay, so that seems vaguely sensible. Now we replaced all of this stuff with something like const logical entities model by reference M. That probably will be sufficient. Okay, so what we're going to do then is let's just do a couple of these and see if there's a macro waiting for us here. Yeah, seems simple enough. Okay, so let's say I'll do this guy. Right, so the macro is going to be go to the next one in grep. Just go down a few. Delete this guy, paste this guy, and you're done. Now, so it's going to take a little while because we are loading these files. So, as you can see, you can follow the progress here. It's going very slowly. And also, every time I touch the mouse, Emacs dislikes it. Right, so what we're going to do then is just go through these guys, at least all the easy ones. Sadly, we didn't do the best of greps because we have included a lot of rubbish in the grep. Just have to keep an eye. Right, as you can see here, we are now no longer in the useful grep. So what we'll do is we'll just jump over a few of these guys. Perhaps this guy here would do. Now, as I probably said in the past, oh, another one that we shouldn't really be touching. Right, this might require a bit of manual intervention now. Let's make sure we don't cause havoc here. Yeah, I think we're in a good area now, so let's just execute the macro again. So while I'm executing these macros, so as I said in the past, normally we don't really want to modify generated code manually. Normally we want to just change the template and regenerate everything. In this kind of cases where the code generator gets itself in a bit of a tangle, where we are trying to modify some code and then we're halfway to a refactor, and then it's really difficult to understand how to modify the templates in a way that the code generator doesn't break. What we tend to do is we tend to sort of do a hack, really. We tend to just do a little bit of, well, depends on what you mean by little, but we do some manual modifications just to get us going, and then we take that as the baseline really, and then we will update the templates to match the things that we changed manually. So we've got let's see what we're doing for time, another 40 odd minutes. So here, as you can see, I'm having a problem. So this chain now is going to have to change. That's fine, we will just do exactly the same change. And the change is merely to supply the model. And then we just, this is quite annoying actually. I don't really like when we're a few characters away from and really the reason why this is happening is because we were a bit lazy and we did not do any usings here. So let's just do a few usings to make our life a little bit easier. One thing that annoys me is that we always end up doing the using. Let's just undo this. Yeah, and as you can see, there's a few things here that are quite obvious. Obviously duplicated. And we know for sure where they are, so there's no need to have a full path. I'll leave model because model is quite common. It's quite common that we have models in different models, so it's not exactly easy to know which one's which. So apply. I wonder. It actually looks sensibly. I think that's just an LSP issue there, so I'm going to ignore that for a second. This supply here, though, it does need to be changed. So we need something like context. Not model, but logical. Right, so hopefully this will now allow us to move forward. Right, now then, we are now entering the templates. So for the templates, as you can imagine, this is now going to be quite tricky. So all of the templates are now likely using the assistant. Well, not all of them use the assistant, I guess. So I think all we need to do, it sounds complicated, but I think it might be easy actually. We just need to update these signatures to have the model. Let's see if this is sufficient. And now, because we are not using the model, and this will be the case for a lot of the helpers, we need to comment it out. Now, of course, this is not exactly brilliant, but remember, the helpers altogether are going to be removed. I really didn't want to touch the helpers code at all because of that, but such is life. So now there's lots and lots of helpers. I suspect we will have to do this change quite a few times. Okay, so the compiler is now helping us. One good thing actually of looking at the generated code from this perspective is that you do get the error messages, so if you're editing the templates directly, it's not quite as easy. You have to first generate and then get the messages. So sometimes it is useful to edit things manually. Okay, so is enabled. Now, probably... okay, right, I know what the problem is. I assume that we've already fixed the header for is enabled, which we did. So now all we need to do is to fix the implementation. Right, so we're getting to a point where you can clearly see there's going to be a mass amount of changes here. They're all going to be exactly the same. And so we don't really want to be doing this one at a time because it will take too long. So what we want to do instead is to find the template. By template I don't really mean a template, I mean find the pattern. Because we can't really code generate at the moment. The code generator is just too broken. It will be very difficult to untangle these changes and to get the code generator to generate again. So instead, what we're going to do is we're going to say, okay, this guy seems to be a good example of the kind of things we want to do. Make sure it goes green. Actually, it's not going green. Right, so let's hop over to coding area. So this assistant is still here. Okay, cool. Instead of assistant, we'd expect the stream. And then we just need to update all of these guys to become up here. So we just want to then say change all of these guys to this, and away you go. Okay, so that seems to be the pattern, the general pattern that we need to do for all the helpers around here. So now that we got that, let's just stop doing them one by one via the mainly tired is not happy. So instead of doing one by one, we need to locate all the helper transforms. So all these guys here. So let's say we do a mark files regex and say we want everything that ends okay, and then let's say we do I never quite remember how to reverse a mask. So direct revert marks. Is a simple way to invert, revert. I think it is invert actually. One of the problems I find with dired is that if you don't use it all the time, you end up forgetting the commands you learn. Let's try invert. Invert selection, that's the one. Direct toggle marks, of course. Okay. and then just need the diode kill, I think. Right, so I need the one that's not actually deletion, but just removal. Diodes, remove. No, we don't really want to remove. This Google is not really being very helpful here. We just want to remove them from selection. So otherwise we're going to end up deleting these buffers. So diodes, let's have a look at the options we got here. Undo, mark, if okay, summary. There is a very simple command for this. I thought it was kill, to be honest. Ah, here we go. Kill line. Pretty sure kill line. Let's have a look at that. Okay, so kill line doesn't actually delete anything. I can prove this by looking at git stage everything. You can see there's very few deletions here. You would have lots and lots of deletions there. So okay, so now we have the buffers that we're interested in. So toggle, just have to remember to toggle. And now we can just open these buffers. All of them are gonna probably have errors. And if we just do other, one thing that diode is not very clever is it doesn't use the top bit, but it's fine. So where are we here? This looks good. I'm just gonna copy all of this. And other. This looks good. Other. This looks good as well. Seems to me that we've done some of this work before. Not totally sure why I have so many of these things that are actually looking good. Well, not all of them, so seems we've done some of the work, but not all. And then we need the model here. And where we need the model, we also need... Actually, I think we could just reuse the last update. So, well, of course we forgot about those streams. So, by reference os. Now let's just copy all this into the clipboards. Kill ring, should I say? Enable looks good. Apply looks almost good. Similarly, it's interesting that these helpers are all in different states. They must have been doing some experimentation here. This is one of the difficulties of doing work and then it's changing to do something else. So you end up doing bits of disconnected work, really. Hard to remember what you were doing. I probably moan about this quite a lot, I don't even remember, but I'm sure I do. I mean, there's nothing for it, you can't moan. It's just what it is. But okay, so if I now do a G on my diode, lo and behold, we get all the files back. Okay, so that is... let's have a look, we were in hash, okay? So I/O is going to be a bit more interesting. We still have that diode problem, so... For some reason I don't seem to be able to delete this window, that's fine. Let's just get rid of that then. So if that was hash, next will be IO presumably. Right, now hopefully this will be a bit easier. So diodes, mark files, regular expression. We want all these guys. Diode toggle, diodes remove, and here are the helpers, the window. Now to make things more interesting, these guys will be slightly different. So with these guys, okay, as you can see, we've done that already, and we've done some other things here. Not entirely sure why make scope namespace formatter is not correct. That definitely is going to be a problem, so fix the easy thing first. Now, why is scope namespace formatter an issue? What we'll do is, let's not lose our nice setup here. What did I do? What we'll do is we'll jump over to, I don't know, something like the RG area, and then we will go back to our help upper transform. And as you can see here, the scope namespace formatter does exist. It just requires a couple of parameters. We could be lazy. I mean, we already have a model, and we are supplying this model all over the place, so I'm afraid we will just be lazy and replace these guys here with this guy, just to make our life a little bit easier. And then in here we can say something like const auto ts m dot equal space, perhaps. Well, that would definitely be tsv presumably, but we do have a problem with ts. Now I think I'm not sure what TS would have been, so let's jump quickly to where the errors are coming from. And perhaps the assistant could help. Right, so the assistant does not seem to have a version of, well, the technical right, so what we've done, of course, in our cleverness is we hard-coded the technical space, so we can't do that. Right, so I'm gonna have to do something else. This is again not ideal, but just have to bear with me. Well, we're just gonna take the technical spaces from the output technical spaces with a certain amount of certainty that this will be populated and populated correctly. Big hack, but and of course probably needs something like let's just see what that variable here should be. Use nesting, so let's just say something like this. Const bool use nesting, and then we can say something like ts is equal to let's just go for a couple of usings here. So if the ts is C#, well, we know for sure we can just get away with it. Or if the TS is C++ and TS version is 17. I mean, really clearly you're going to tell me they should be 17 or higher, but that's the current hack that we have. This whole thing is one big hack, so we just have to continue the hackery. Right, so that is equivalent to what we had there before. And now, hopefully, we should be able to call this method with just by supplying a model. And that would then mean that this guy is no longer commented out. Okay. So this is rather painful, but oh, okay. More problems. So let's have a quick look at what right, we made a mistake here. We made a function that is not const. Yeah, hate when this happens. Never quite sure where to put the const. So I should think that pretty much all of these methods should be const. How are we doing for time? Close to the end. 41 minutes in our recording. Hopefully the volume is okay. We've been having problems with the sound. Right, where are we then? This is the first problem. Now the second problem is we need a stream, so that's fine. And there we are. So now finally we solved the problem with that guy. This will be a common problem, I'm afraid. So made a mistake there. Let's just close that file for a second and press other. Okay, for whatever reason, sometimes diode is just not very clever. I think we need to give it a hint. So optional helper, there we are. So is enabled is the first problem. Applies the second. I mean, really here it's easier to copy and paste, I should think. As you can imagine, all of this would be much easier if we could cut and write, but such is the life. This also reminds me that another problem that we have of doing these things as you go along is that it's easier to so let's just remember what we're doing here. It's easier to do all these changes in one go because it's quite fresh in your head. When it's not fresh in your head, then you're more likely to make mistakes. So streaming for type. Now, what did we say in streaming for type? I'm sure streaming for type should ask. Well, I thought we were going to ask for a model, but clearly not. I wonder actually if there is any cases where we're going to require a model, and if not, we can just remove that. But we will have to see. But again, diode's not very clever. I wonder what determines where to put the window and diode. Let's have a look. Right, so that solves the problem of is enabled. And then not quite sure how many assistants we got, but there's quite a few. There's not much we can do, to be honest. Again, streaming for type is the easy one. Which is nice. Hopefully. Next one. So all of the ones that are a bit more complicated are all in I/O. This is exactly where it would be better to have a separate window with just the stuff that we're interested in, I think. But that's fine, let's just continue. There's only a few to do here. Or not, actually, let's just do that. Let's jump over to... we don't have any free areas anymore. We'll create another one. Let's create a 13 here, just temporary area. And in this area, we're not going to have anything other than what we're interested in. Oh, I think I just killed flight check. But this area is actually designed just purely for the updates we're trying to make. So, pair helper transform is fixed. And that appears to be fixed as well. So what's next? P3 perhaps? Right, so as you can see now, diode is doing something slightly more sensible. Of course we can't see flight check, but that's how it goes. As you can imagine, you could, there's many ways of doing this a lot faster, but we're just gonna do the quick and dirty way. So this is something like this. Right, that seems to be alright. So actually, I wonder if we just copy everything except for the method name. Just a little bit of a speed boost there. So as you can imagine, we still need to do this for all of the templates. Which is not ideal, but there you are. We could do the templates now, but if I change the templates, I won't be able to regenerate. So first we need to get a code generator that compiles and generates. Otherwise, not a lot of point in doing the templates. So up to now, we have not found a streaming for type that requires requires a model really. So we shall drop that from the interface in a second, because I think this is only used here. Mentioned this in the previous video as well, but it was worth repeating it. When you're creating this kind of thing, it's important it's important to find the sweet spot in terms of how much samples you need to prove a point versus how much well, at some point you're going to realize that adding more of X does not add any more value, and it adds a cost. And that's the classic case here with Dogen. We were lucky that we only added a few helpers, because when we were doing the helpers, we were convinced that the helpers were the right way of doing this. Didn't copy the right thing. We were convinced that the helpers were the way forward, and so we thought we just created quite a few helpers, and maybe I've done a bit too many, to be fair. But the key thing is that if we added even more, we'd now be in a very tricky situation, because as you can see already, just the number of helpers we've got is already quite cumbersome every time we need to make a change. And we don't even want helpers in the future. So it would have been an investment that would have not really paid off. So it's one of the hardest things to do in programming, is to find these sweet spots where you experiment sufficiently to prove a point, but not so much that when you figure out that that's actually wrong, that it's going to take you forever to fix it. It's quite tricky, really. Right, so now then, interesting that one of these didn't require scope namespaces. Right, here we are, streaming for type. Let's see if these guys, yeah, these guys are different, I think. No, they're not actually. Right, then that's I/O. So that's good. So don't think we're gonna have too many helpers in lexical casts. Don't think we have any helpers at all. ODB. Will be a few here. Serialization. So let's do the usual. So let's find the helpers. Oh, there's only one, so there's no point to do too much faffing around here. Right, is enabled is not quite. This is enabled, so grab it from hash perhaps. You may think the life of a programmer is quite glamorous, but in reality half of it is doing work like this. You reach a conclusion and then you have to act on it, and a lot of times the acting on it is not actually very clever stuff, it's just, well, modifying stuff. There we are, the serialization. Test I don't think has any helpers. Test data will probably have quite a few. Okay, so here let's go back to our marking, then toggle. We should really start using the shortcut, shouldn't we? Toggle, kill. Right, so I think all of these guys will have an is enabled as trivial. That is to say, just return true. That guy. And hopefully fairly trivial applies as well, from our perspective anyway. Don't think we need a model. And I think that's going to be the case for pretty much all of the guys that are next. Well, the guys that are in this thing, this facet, so bit of luck. Okay, so whilst all this boring stuff is going on, we probably should recap what we're doing and where we are. We are also quite close to the end of this video as well, so what we're trying to do at the moment is we are just trying to get the helpers decoupled from the assistants, and what that's going to give us is the ability to move the helpers to the text model first without having to drag everything in one go. I mean, for starters, we are fixing a very bad problem anyway, which is a circular dependency between assistant and helpers. But that is not actually a particularly meaningful thing to do, given that the helpers are going to go. So what makes it meaningful is the fact that we're trying to drag these guys across to the text model, all of them. And with that circular dependency, we can't really do it. So that's why we need to go through all this boring stuff. And the reason why we're not doing this all in a generated fashion is purely because the code generator is in a bit of a state. Not sure why this is not going green. It's taking its time. Making sure there's no messages. Okay. Right. And this video will finish when we get close to an hour. Yeah, I got another 8 minutes. So whatever we get done in that time, I don't think we'll finish all the hoppers, but get close to it, hopefully. So these videos they might be quite boring to watch, I guess, but they do achieve the objective that we had. Well, the first objective, of course, is just to get us going. It's always easier when you're recording to motivate yourself to keep going. But the second objective as well is I wanted to paint a fairly realistic portrait of the work, because I think once you look at the end results, it may appear this is all quite magical and it's all quite straightforward, and in reality there's a lot of boring, not particularly sexy work. I wouldn't say this is the majority of the work, but there's a very significant amount of it, and I think this is not quite portrayed realistically. When you hear people talking about model-driven engineering, it seems as if the tools generate everything. But actually, in order to get the tools to generate everything, you first need to do a lot of the boring work. And much of that is empirical analysis. And empirical analysis is just another fancy word for saying you have to do things manually first, and then once you're happy enough that the bit that you've done manually works, then you go and you generalize it. Because if you try to generalize it first, then you're going to run into a whole lot of problems. And so a great example of that is what we've been doing up to the previous sprint, where we tried to do lots and lots of generalizations of well, it's hard to describe it really, but we tried to do a whole lot of work that was very, very generic and didn't really have the empirical analysis. And then our final conclusion was that actually that was just too difficult. Unless you're a person that is like really, really competent at abstraction, you will find that really, really generalized work is just too difficult for a normal brain to cope. And so it just goes really, really slowly. Whereas this kind of work is the opposite. It's very, very boring, it takes a very long time, but it's not creative. This is not, I'm not actually using any of my brain, that's why I'm talking to you while I'm doing this. And what this enables me to do then is enables me to have the empirical samples that I then need to do the generalization. In other words, if I now go to a template and try to fix the code generator, well, all the code generator needs to do is to generate exactly the same code that I've manually generated, which is really what the people in the MD circles will tell you to do anyway, to always have the samples first before you start to generalize things. It's just that that may sound quite clever, but actually this is what it means. Lots and lots of manual work. Manual labor, I guess. And programmers sometimes tend to believe they're above manual labor for whatever reason, whereas I disagree. I think actually the principles of manual labor, the hard work that you get from manual labor, are the things that give you the discipline to become a programmer, because it's really the ability to just do a lot of mundane tasks. Not always, of course. You don't really want a programmer that is always copying and pasting, so you really need to be able to say there's a task that needs copying and pasting and we're just going to get on with that, and there's a task that needs generalization. This is sort of a, if you were to generalize this principle, which is quite ironic given that we're talking about generalization, but if you were to generalize this principle of what we're doing here in terms of programming, The difficulty is to determine at which point you generalize and which point you copy and paste. A lot of times we do the wrong thing. So in other words, you can spend hours on end creating tools to do a task. And the tools are really nice, but in reality, from a perspective of a business, they don't add any value. So the business doesn't really care if you just go and copy and paste a whole load of stuff and deliver something in production, because that's what the value is. And if it takes you 10 times longer to generalize, actually you just added negative value, because the business could have done stuff and they could have figured out how to make money, I guess, at the end of the day from that code, and they didn't, because they were waiting for you to finish with your super clever fancy generalized version. So the business would tell you this is not a very good approach. However, the reverse of that currency or that coin is that sometimes the opposite happens, where the business is keen on you just doing a hard copy and paste solution, and then in the future they're going to be the ones saying, well, why does it take so long for everything to get done? And the reason why, of course, is because you are copying and pasting, which is sort of the paradox of programming, I guess, if you like. So you need to be able to tell. So let me just use my brain for a second. You need to be able to distinguish between these two cases, and only experience gives you that. You could spend as much time you'd want at university discussing these matters, but you would not really learn anything about it. I think you need many years of coding to be able to tell. But the gist of it really is, if you're doing something that involves in the future there's going to require tens or hundreds or thousands of the same, then you know for sure copy and pasting is not going to be the solution. If you're doing something that is actually going to require one-time change, then, well, perhaps copying and pasting is not too much of a problem. That's kind of the gist of the algorithm, I guess. And I reckon we're done. Okay, so with these changes, quite neatly, as we reach the end of our video as well, with these changes, we probably are quite close to compiling. Not 100%, but close enough, I think. We know for sure the tests are going to break, because of course the code generator is generating the modified, well, the non-modified code. So that's definitely not going to work. So we're not going to cover in this video the change to the templates, because we need to break. But now we're going to pick up the cases where we just didn't quite do the right thing. It's only going to be a couple. And hopefully this will take us to where we want to be. That's where, of course, having fly check is really good. But this is expected. We're probably going to have one or two of these. Oh, interesting. We did say... So we were under the impression that test data didn't have any helpers. Not sure why. Oh. Okay, that was a bit of an incorrect impression. Let's have a look at what this thing's saying. Oh no, actually we did do test data. Let's just go back to compilation. It's probably just a few cases where we didn't do the right thing. Hopefully. So these were going to be the simple cases, so we just need to return true. I'm hoping that we just missed one helper or another. And the problem of talking while coding. Perhaps it's more than one or two. So let's just go back to the old diode area. Let's just open these guys. Right, here we are. So I wonder if we did a few and then got bored and moved to the next facet before we completed the task. The difficulty of copying and pasting. I mean, every developer will tell you that, you know, copying and pasting is evil. The reason why is because we all had to deal with legacy code bases, with half-baked implementations, and developers that went in and were under pressure to deliver something. I mean, probably even ourselves, in very difficult conditions, and had to deliver something to production, and got the next deadline, and then the next. And then what tends to happen in a regular code base is that you start accumulating a lot of technical debt. And the technical debt never really gets factored into schedule, and then sooner or later the code base just becomes unmaintainable. That's why we profoundly dislike copying and pasting, because copying and pasting is just a sign of laziness in many cases. And then when people become lazy, somebody will eventually pay the cost of that laziness, really. And it tends to be the developer that comes 10 years later. So that's why pretty much any developer, particularly senior developers, would immediately tell you, do not start copying and pasting things. You're just going to pay for the cost later. But the other side of copying and pasting is, well, actually, it's not the side of copying and pasting, it's the side of continual refactoring, really. What really you should do, and this is what we do in Dogen quite a lot, is you should always just implement things quickly. Just implement it, just see what happens. Let's see how the interface looks like. You should just go and implement something, and okay, that actually looks alright. What's the problem with this, I wonder? We actually are using the model. So yeah, I think it's important to sometimes just implement something, anything. Get that thing into production, test it, and by testing it, I don't really mean testing it in a TDD or okay, so I think the problem is we do not have an ID in the helper transform. Okay, right, so we are beginning to touch C# code. Right, let's just make sure we do not do that, because this is already very complicated as it is, and we don't really want to pick C# up now. So, not that guy. But we have no option, actually. We have no alternative because... Yes, we have an alternative because there's only one header file, I think. I think the problem is we only have one way generating helper, so actually, unfortunately, we have to do C# as well as C++. That's okay, it's not a problem. There's only a few helpers in C#, so let's just go back to where we were in the errors and address those. Should be fine. Which makes me think see what the helper, sorry, what the compilation is saying. I'm not entirely sure why we don't have an ID. Let's have a look at the interface again. Yeah, we do have an ID, interestingly enough. Clearly. Wonder. back the way it was. We didn't actually have it in memory, so I can't quite recall. Okay, right. The problem we have here is that we shouldn't really have a helper transform at all. So let's just get rid of it. Yes, please. And then if you just go to the include, we should also get rid of this guy. Right, so we got rid of the helper transform in C#, and now I think we're probably going to have 1 or 2 breaks. And the breaks will all be related to us referring to the wrong helper. And presumably context is going to be behind a lot of the problems. There we are. So this guy, we just want to say, just use the helper transform from your parent. Now, not totally sure why this is moaning. Perhaps he wants us to say text.transform. Yeah. Right, so we didn't really want to pick this fight just yet, but there is no other way. And it doesn't really matter really. It has to be done at some point, so this should do it, and then C#. Right, so I suspect we will be able to get away with only a few changes here. There's only 2 helpers, I believe, in C#. Again, same thing. Once we realized there was a pattern, we decided not to go crazy on these. There's only 2, because we knew this is not the right way to do things. Right, now then. Let's keep going here until we start seeing some light at the end of this tunnel. Seems to really not like the helper transform. What we'll do is, just to be on the safe side, we will ensure this is really pointing to the right thing. And now right, I think we're going to need to do a bit of thinking here. We shouldn't really be getting this many errors, I think. So anyway, we ran out of time. We're already past an hour. Okay, so we'll just summarize quickly what we've done then. So we've more or less done almost all the helpers. I think pretty much C++ is done. All these helpers are now using, so it's just to get us above again to see what we're doing. So we're trying to remove the helpers interface from C++. That's done. We removed it. The code is now more or less compiling. Templates still need to be updated. We also removed the helper from C#, although to be fair, we did not do it from here. We're still in the process of updating the code for it to match. And then we need to remember to update all the models to reflect that change. Probably do all of that before the next video, and then resume when we got something a little bit more exciting, because you probably get the gist of the work now. Just rinse, repeat, till we get to a point where the helpers are in a decent enough state, completely isolated from any dependencies on the technical space specific models. And when that's the case, we're then just going to very, very carefully move one helper at a time, or at least one facet at a time, all to the text model. So that's probably something for the next video. Thanks for watching.